Question 1. RBI process. Risk ranking. In the context of risk-based inspection, RBI, how should the risk assessor prioritize inspection schedules for a facility where certain assets have been identified as high risk based on both probability of failure, POF, and consequence of failure, COF? A. Focus inspection efforts on the assets with the lowest POF scores, as these are the most stable. B. Prioritize assets with high COF but low POF scores, as their impact could be severe, even though the likelihood of failure is low. C. Prioritize assets with both high POF and high COF scores, as these assets present the greatest overall risk. D. Schedule inspections for all assets equally to ensure fairness and avoid bias. Answer. C. Prioritize assets with both high POF and high COF scores, as these assets present the greatest overall risk. Explanation. In risk-based inspection, assets are prioritized based on a combination of probability of failure, POF, and consequence of failure, COF. The primary goal is to address the greatest risk to safety and asset integrity. When both POF and COF are high, the likelihood and impact of failure are critical, necessitating higher priority for inspection. This is in line with industry standards for asset integrity management, as laid out in the API 580 guidelines killexams.com API. Conversely, prioritizing based on only one factor, like COF, could miss high-risk assets with a more likely failure but lower consequences. Question 2. Inspection techniques. Non-destructive testing, NET. Which of the following non-destructive testing, NDT, methods is most suitable for identifying early-stage corrosion in a pipeline that cannot be visually inspected due to inaccessibility? A. Ultrasonic testing. B. Magnetic particle testing, MPT. C. Visual inspection, VT. D. Radiographic testing, RTA. Answer. A. Ultrasonic testing. Explanation. Ultrasonic testing is an NDT method widely used for inspecting materials for thickness measurements, corrosion, and cracks, especially in areas that are difficult to access. UT uses high-frequency sound waves to detect subsurface flaws, making it highly effective for detecting corrosion in pipelines that cannot be visually inspected. Killexams.com. Magnetic particle testing, MPT, is effective for detecting surface cracks in ferromagnetic materials but would not be ideal for internal corrosion. Visual inspection, VT, is limited by accessibility and is not suitable for internal corrosion. Radiographic testing, RT, can detect internal flaws, but it is generally used for thicker materials and might not be as effective for early-stage corrosion in pipelines, which UT can detect with higher sensitivity. Question 3. Scenario question. Risk management. Scenario. Mr. Carter is the asset integrity manager of a petrochemical plant. He has just received a report indicating that a critical valve in the high-pressure system has been flagged with a high probability of failure, POF, due to erosion but has low consequence of failure, COF, because the valve is not in a critical safety or process area. Given the plant's resources and the need for cost-effective risk management, what should Mr. Carter prioritize in his risk management strategy for this asset? A. Immediately replace the valve to mitigate the risk regardless of cost or operational disruptions. B. Delay inspection and maintenance since the valve's failure would not have serious consequences. C. Schedule regular monitoring and periodic inspection to track the valve's condition while implementing a contingency plan in case of failure. D. Conduct a full risk assessment of the entire facility before making any decisions on the valve, ignoring the urgency. Answer. C. Schedule regular monitoring and periodic inspection to track the valve's condition while implementing a contingency plan in case of failure. Explanation. Given that the valve has a high probability of failure, POF, but a low consequence of failure, COF, it is essential to balance risk with available resources. Scheduling regular monitoring and periodic inspections will allow Mr. Carter to assess the valve's condition over time, identifying any potential failure trends without unnecessarily incurring high costs or disrupting operations. Killexams.com. This strategy aligns with best practices in risk management, where assets are monitored closely based on their risk profile. Immediate replacement, option A, may not be cost-effective, especially if failure consequences are low. Delaying inspection, option B, could expose the plant to unnecessary risks if the valve fails unexpectedly. Conducting a full risk assessment of the entire facility, option D, might delay necessary actions on the valve and is unnecessary since the specific asset has already been flagged. Question 4. Risk assessment. Damage mechanisms. In a petrochemical plant, an asset has been identified as being vulnerable to both stress corrosion cracking, SCC, and external corrosion. The asset's probability of failure, POF, is moderate, and the consequence of failure, COF, is high due to its location in a critical process area. Given this situation, what should the risk assessor prioritize in the inspection and maintenance strategy? A. Focus on monitoring the asset for stress corrosion cracking SCC since it has the higher likelihood of occurrence. B. Prioritize external corrosion inspection due to its immediate visual indications and higher visible impact. C. Implement a comprehensive risk management approach focusing on both stress corrosion cracking, SCC, and external corrosion, given the high COF. D. Limit the inspection to routine visual checks and only perform further investigation if any visible signs of failure occur. Answer. C. Implement a comprehensive risk management approach focusing on both stress corrosion cracking, SCC, and external corrosion, given the high COF. Explanation. In this case, stress corrosion cracking, SCC, and external corrosion both present risks to the asset. But given the high consequence of failure, COF, a comprehensive risk management strategy is crucial. The high COF justifies addressing both damage mechanisms to avoid potential catastrophic failure. API 580 emphasizes the need for a holistic approach when the consequences of failure are significant, especially in critical process areas. Colexams.com. Focusing on only one damage mechanism, options A and B, would not be sufficient in addressing the asset's overall risk profile. Routine visual checks, option D, would not provide the necessary insight into internal or subsurface damage, potentially missing critical signs of SCC or corrosion that may lead to failure. Question 5. Inspection techniques. Fitness for service, FFS. Which of the following factors is most important when conducting a fitness for service, FFS? Assessment of a corroded pressure vessel as part of a risk-based inspection, RBA, program. A. The thickness of the vessel wall at the corroded area and the calculated remaining strength of the material. B. The operational temperature of the vessel at the time of inspection. C. The age of the pressure vessel and the duration of its service. D. The manufacturer's recommendations for maximum operating pressure. Answer. A. The thickness of the vessel wall at the corroded area and the calculated remaining strength of the material. Explanation. When performing a fitness for service, FFS, assessment on a corroded pressure vessel, the most critical factors include the thickness of the vessel wall and the calculated remaining strength of the material. These measurements are essential in determining whether the vessel can continue to operate safely under its current conditions. This aligns with the principles outlined in API 579, Fitness for Service, which focuses on assessing whether a component can safely remain in service despite degradation. API. The operational temperature, option B, is relevant but secondary to the material's integrity in this context. The age of the vessel, option C, or the manufacturer's recommendations, option D, are less critical than directly assessing the structural integrity and strength. Question 6. Scenario question. Roles and responsibilities. Scenario. Mr. Alvarez is the lead inspector for refineries risk-based inspection, RBA, program. He has just been informed that a pipeline carrying hazardous chemicals has reached a high-risk status due to increasing signs of corrosion, with a moderate probability of failure, POF, but a high consequence of failure, COF. The refinery has strict safety protocols but limited budget for major repairs. What should Mr. Alvarez's immediate action be in this situation? A. Prioritize immediate shutdown of the pipeline for repairs, despite the limited budget, to ensure the highest safety level. B. Perform a detailed risk assessment and develop a prioritized inspection and maintenance plan to extend the pipeline's life, including a contingency plan for failure scenarios. C. Ignore the risk due to budget constraints and rely on the pipeline's existing inspection schedule to assess the situation over time. D. Recommend reducing the frequency of inspections for the pipeline to save resources, as the risk of failure is still considered moderate. Answer. B. Perform a detailed risk assessment and develop a prioritized inspection and maintenance plan to extend the pipeline's life, including a contingency plan for failure scenarios. Explanation. Given the high consequence of failure, COF, and moderate probability of failure, POF, Mr. Alvarez must take a risk-based approach to balance safety, operational continuity, and budget constraints. API 580 guidelines stress the importance of a prioritized inspection and maintenance plan that addresses both current risks and potential future scenarios, with contingency measures in place for high-risk assets. CalExams.com API. This allows for a managed approach to risk, reducing the likelihood of failure without committing to expensive immediate repairs. Immediate shutdown, option A, may not be necessary unless the risk assessment justifies such an action, and it could be overly disruptive and costly. Ignoring the risk, option C, is contrary to the principles of risk-based inspection, which advocate proactive management. Reducing inspection frequency, option D, could increase risk, especially for an asset with high consequences. Question 7. RBI Program Development. In the development of a risk-based inspection (RBI) program for a new chemical plant, what is the primary purpose of establishing a risk matrix to prioritize assets for inspection? A. To determine the exact cost for inspecting each asset over the next 5 years. B. To provide a visual representation that helps identify which assets are at the highest risk of failure based on both probability of failure (POF) and consequence of failure (COF). C. To comply with regulatory requirements without considering the operational conditions of the plant. D. To identify areas of the plant that need the most operational downtime for repair and maintenance. Answer. B. To provide a visual representation that helps identify which assets are at the highest risk of failure based on both probability of failure (POF) and consequence of failure (COF). Explanation. A risk matrix is a tool used to visualize and prioritize inspection efforts based on the likelihood of failure, probability of failure, and the impact of failure, consequence of failure. This matrix is central to an effective RBI program as it allows asset managers to allocate inspection resources where they are most needed, based on an asset's risk profile. This approach aligns with best practices outlined in API 580 and is a critical tool for improving safety and operational efficiency. CalExams.com. Option A is incorrect because the risk matrix is not designed to estimate costs, but to identify risk. Option C is not correct, as the risk matrix is meant to guide decisions based on the plant's actual operational risks. Option D would misinterpret the purpose of the matrix, as it focuses on safety and risk, not downtime. Question 8. Fitness for service. FFS. Assessment. Which of the following is true when performing a fitness for service? FFS. Evaluation on a corroded pressure vessel. According to API 579 and industry best practices, A. FFS evaluations are only necessary for vessels that have experienced catastrophic failure. B. The assessment focuses only on the age of the pressure vessel and ignores other operational factors. C. The evaluation takes into account the remaining strength of the vessel, including its corrosion levels, to determine if it can safely continue to operate. D. FFS evaluations are primarily concerned with replacing the vessel immediately if corrosion is detected. Answer. C. The evaluation takes into account the remaining strength of the vessel, including its corrosion levels, to determine if it can safely continue to operate. Explanation. Fitness for service. FFS. Evaluations are conducted to assess the structural integrity of a component, such as a pressure vessel, by considering factors like corrosion levels, remaining strength, and operational conditions. The goal is to determine whether the asset can continue operating safely and for how long, considering both its current state and future risks. This approach is aligned with API 579, which guides how to assess damaged or degraded equipment, including fitness for service evaluations. CalExams.com. Option is incorrect because FFS evaluations are performed before catastrophic failure to assess risk. Option B is incorrect because age alone is not the primary factor. Corrosion and other operational conditions are critical considerations. Option D is incorrect because immediate replacement is not always necessary unless the evaluation indicates that the asset is unsafe to operate. Question 9. Scenario question. Risk assessment and mitigation. Scenario. Ms. Hernandez is the integrity manager of a refinery and is reviewing an RBI assessment for a heat exchanger in the facility. The asset is located in a non-critical area, and its risk analysis shows a low probability of failure, POF, but a high consequence of failure, COF, due to its potential to cause a chemical leak if it fails. Given the situation, what action should Ms. Hernandez prioritize to ensure safety and operational integrity? A. Immediately schedule the asset for replacement to eliminate any risk of failure. B. Perform a detailed inspection of the heat exchanger and implement a monitoring program while developing a contingency plan in case of failure. C. Continue operating the heat exchanger with no further inspections, as the low POF indicates that failure is unlikely. D. Ignore the heat exchanger's risk assessment and rely on a reactive approach, only addressing failure after it occurs. Answer. B. Perform a detailed inspection of the heat exchanger and implement a monitoring program while developing a contingency plan in case of failure. Explanation. Given the low probability of failure, POF, but high consequence of failure, COF, Hernandez should adopt a proactive approach. The best course of action is to inspect the asset thoroughly and monitor its condition to detect any early signs of failure. Furthermore, a contingency plan should be in place in case the heat exchanger fails, ensuring that the refinery can react quickly to mitigate the consequences of failure. This approach follows the API 580 principle of balancing risk through proactive inspection and risk mitigation strategies. Killexams.com API. Optional media replacement may be excessive, especially with a low POF. Option C. Continuing without inspection is unsafe given the potential consequences. Option D. Reactive approach is not aligned with industry best practices for managing high COF risks. Question 10. RBI program management. Which of the following is the most critical aspect when maintaining and updating a risk-based inspection RBI program over time? A. Ensuring that the inspection intervals remain static and do not change based on asset condition. B. Routinely revising the risk matrix based on updated inspection results, asset performance, and changes in operating conditions. C. Limiting the scope of RBI to only high-risk assets and ignoring lower-risk components. D. Following. A fixed inspection schedule regardless of the plant's evolving operational circumstances. Answer. B. Routinely revising the risk matrix based on updated inspection results, asset performance, and changes in operating conditions. Explanation. An effective RBI program requires continuous evaluation and updates. The risk matrix needs to be regularly revisited to incorporate new data from inspections, changes in operating conditions, and observed asset performance. This ensures that the program remains aligned with the current risk profile and that resources are allocated appropriately. API 580 stresses the importance of dynamic risk assessments that reflect real-time information about assets, conditions, and operational risks. Killexams.com API. Option is incorrect because inspection intervals must be adjusted based on asset condition and risk. Option C is not aligned with RBI principles, as it advocates neglecting low-risk assets, which could lead to overlooked risks. Option D is also incorrect because static schedules don't adapt to evolving operational realities. Question 11. Damage mechanisms. Corrosion. Which of the following statements is true about the role of corrosion in the risk-based inspection RBI assessment process? A. Corrosion is only considered a risk when it reaches the stage of pitting or perforation. B. The assessment of corrosion in RBI should include both external and internal inspection techniques to identify active and hidden forms of damage. C. Corrosion is less important than other damage mechanisms, such as fatigue or creep, in the risk assessment process. D. External corrosion inspections can be skipped if the material is known to be resistant to corrosion under normal operating conditions. Answer. B. The assessment of corrosion in RBI should include both external and internal inspection techniques to identify active and hidden forms of damage. Explanation. Corrosion is one of the most common and dangerous damage mechanisms affecting industrial assets. In risk-based inspection, RBI, it is essential to use both external and internal inspection methods such as ultrasonic testing, radiography, and visual inspections to detect corrosion in its early stages and prevent failures. This comprehensive approach helps identify both active corrosion, ongoing degradation, and hidden corrosion that may not be visible externally. API 580 highlights that proper corrosion management is integral to the success of an RBI program, especially for critical assets. Option is incorrect because corrosion can cause significant damage even before it reaches perforation. Option C is incorrect as corrosion is often the most critical damage mechanism in industrial settings. Option D is incorrect because even materials resistant to corrosion can still experience degradation in certain conditions, necessitating thorough inspections. Question 12. Scenario question. Risk ranking and prioritization. Scenario. Mr. Thompson, a plant engineer, is reviewing the RBI assessment for a heat exchanger in the refinery. The assessment shows that the probability of failure, POF, is low, but the consequence of failure, COF, is extremely high because a failure would result in the release of a toxic chemical into the atmosphere. Based on this assessment, what should Mr. Thompson prioritize in managing the risk of this heat exchanger? A. Given the low POF, he can continue operating the heat exchanger without any additional inspection or mitigation measures. B. He should prioritize a more frequent inspection and monitoring plan due to the high COF despite the low POF. C. He should shut down the heat exchanger immediately for repairs, disregarding the operational cost. D. He should only monitor the heat exchanger's operational performance and ignore potential structural issues, as the POF is low. Answer. B. He should prioritize a more frequent inspection and monitoring plan due to the high COF despite the low POF. Explanation. In this scenario, the high consequence of failure, COF, dictates that Mr. Thompson should prioritize a more frequent inspection and monitoring plan even though the probability of failure, POF, is low. While the likelihood of failure is low, the potential consequences, release of a toxic chemical, are severe, so it is critical to ensure that any early signs of degradation are detected before failure can occur. This approach is in line with the risk-based inspection, RBI, methodology, which prioritizes asset integrity based on both the POF and COF. API 580 encourages this balanced approach to reduce risk to both personnel and the environment. Option is incorrect as the low POF does not justify neglecting the high COF. Option C may be an overreaction, as it bypasses the need for a more measured approach like inspection and monitoring. Option D is wrong because ignoring potential structural issues can lead to catastrophic consequences despite the low POF. Question 13. Risk mitigation and inspection strategy. Which of the following best describes the role of non-destructive testing, NET, methods in a risk-based inspection, RBI, program? A. NDT is primarily used for confirming asset failures after a failure has occurred. B. NDT methods such as ultrasonic and radiographic testing are essential tools for detecting and quantifying potential defects in assets before failure occurs. C. NDT is only required for high-risk assets and not for lower-risk components in the system. D. NDT methods are used only to evaluate the external surface of assets and do not assess internal structural integrity. Answer. B. NDT methods such as ultrasonic and radiographic testing are essential tools for detecting and quantifying potential defects in assets before failure occurs. Explanation. In an RBI program, non-destructive testing, NET, plays a critical role in proactively identifying potential defects such as cracks, corrosion, or wear, without compromising the integrity of the asset. NDT methods such as ultrasonic testing and radiographic testing are used to detect internal and external damage mechanisms at an early stage, which helps to prevent catastrophic failures. These methods are integral to a preventive maintenance strategy and are emphasized in API 580 for assessing asset conditions in advance of failure. Option is incorrect because NDT is used to detect potential issues before failure, not after. Option C is incorrect because NDT should be applied to all assets based on risk, not just high-risk components. Option D is incorrect because NDT is used to assess both external and internal asset conditions. Question 14. Probability of failure, POF, evaluation. Which of the following factors is the most important when calculating the probability of failure, POF, in a risk-based inspection, RBI, program? A. The asset's age and historical performance alone, without considering current operational conditions. B. The operational environment, material degradation mechanisms, and design limitations of the asset. C. The asset's replacement cost compared to its current market value. D. The frequency of inspections performed on the asset, regardless of the asset's operating conditions. Answer. B. The operational environment, material degradation mechanisms, and design limitations of the asset. Explanation. In the context of RBI, probability of failure, POF, is determined by assessing the operational environment, e.g., temperature, pressure, corrosive agents, the material degradation mechanisms such as corrosion or cracking, and the design limitations, e.g., material strength or fatigue resistance of the asset. These factors collectively help predict how likely it is that the asset will fail within a specific time frame. API 580 emphasizes this holistic approach to POF calculation ensuring that risk is assessed based on both asset condition and operating conditions. Option A is incorrect because age and historical performance alone do not account for current risk factors. Option C is incorrect because replacement cost is not a direct factor in POF calculation. Option D is incorrect because while inspections are important, they cannot predict failure without considering the operational factors that contribute to degradation. Question 15. Scenario question. Risk management and documentation. Scenario: Mr. Patel is a senior engineer responsible for managing the RBI program in a petrochemical plant. During an RBI review meeting, the inspection results for several critical assets show signs of severe internal corrosion, but the probability of failure, POF, for these assets remains low. What should Mr. Patel do in this scenario to ensure the safety and continued reliability of the assets? A. Continue normal operations, as the low POF indicates that the assets do not pose an immediate risk. B. Recommend shutting down the affected assets immediately for repair, disregarding operational costs. C. Recommend implementing a more frequent inspection schedule and closely monitoring the corrosion progression while maintaining a contingency plan for failure. D. Ignore the inspection results as the POF is low and no further actions are necessary at this time. Answer: C. Recommend implementing a more frequent inspection schedule and closely monitoring the corrosion progression while maintaining a contingency plan for failure. Explanation: in this case, even though the probability of failure, POF, is low, the severe internal corrosion indicates that there could still be potential for failure if left unchecked. Mr. Patel should prioritize more frequent inspections and monitoring to closely track the progression of corrosion and catch any early signs of failure. Additionally, a contingency plan should be in place in case the asset fails despite the low POF, as this will minimize any potential consequences. This proactive risk management approach follows the principles of RBI as outlined in API 580, which advocates managing risk through a combination of monitoring and contingency planning. Option A is incorrect because it ignores the need for proactive monitoring and intervention in the face of significant corrosion. Option B is overly cautious and may be financially unsustainable without a clear need for immediate shutdown. Option D is incorrect because ignoring the results could lead to unmitigated risks, especially with the presence of severe corrosion. Question 16. Inspection planning and risk assessment. Which of the following strategies is the most effective for determining the inspection frequency of critical assets in a risk-based inspection (RBI) program? A. Using a fixed inspection interval based on manufacturer recommendations without considering current asset conditions. B. Implementing a dynamic inspection schedule that adjusts based on risk, asset performance, and degradation mechanisms. C. Inspecting critical assets only when there is a known history of failure or degradation. D. Assigning inspection frequency based on asset value rather than risk and operational condition. Answer: B. Implementing a dynamic inspection schedule that adjusts based on risk, asset performance, and degradation mechanisms. Explanation: a key aspect of an RBI program is adapting inspection frequency based on evolving asset conditions and risk assessments. As assets degrade over time due to corrosion, fatigue, or other factors, the likelihood of failure changes, which directly impacts inspection scheduling. API 580 emphasizes the need for dynamic inspection planning, which takes into account factors such as risk ranking, failure modes, and operational environments to ensure that inspections are targeted to prevent failures and maintain safety. Option is incorrect because static inspection intervals do not account for actual asset conditions or evolving risks. Option C is incorrect because inspections should be proactive and conducted regularly based on risk, not only when problems are observed. Option D is incorrect because asset value should not be the primary factor. Instead, the risk and potential impact of failure should determine inspection priority. Question 17. Risk-based mitigation strategy. When implementing a risk-based inspection (RBI) program, what is the primary goal of consequence of failure (COF) analysis? A. To determine the likelihood of failure based solely on material strength. B. To assess the environmental, safety, and financial impact of asset failure, including the consequences on personnel and operations. C. To establish an inspection schedule for high-risk assets with no consideration of operational impact. D. To focus on predicting future failures without considering the current impact of failure. Answer: B. To assess the environmental, safety, and financial impact of asset failure, including the consequences on personnel and operations. Explanation: In an RBI program, the consequence of failure, COF, analysis is focused on evaluating the potential impact of a failure on both safety and operations, including environmental damage and financial costs. This helps to prioritize assets that, while they may have a lower probability of failure, POF, could have catastrophic consequences if they do fail. By analyzing COF, organizations can take steps to mitigate risks associated with failure and minimize potential harm. This approach is outlined in API 580 and helps make informed decisions about asset management and maintenance. Option A is incorrect because COF is about the impact, not likelihood, of failure. Option C is incorrect because the primary goal of COF analysis is not about scheduling inspections, but understanding the impacts of failure. Option D is incorrect because COF is about understanding and mitigating real-world impacts, not just predicting failures. Question 18. Scenario question. Risk management and maintenance. Scenario: Ms. Johnson, the lead engineer, is reviewing the risk assessment of a reactor vessel in a chemical plant. The assessment indicates a high probability of failure, POF, due to cracking, but the consequence of failure, COF, is relatively low because the reactor operates at low pressure. What should Ms. Johnson do to manage the risk effectively? A. She should ignore the POF and continue normal operations, as the COF is low and the reactor operates at low pressure. B. She should implement additional monitoring techniques to detect cracks early and adjust the inspection schedule based on the POF, even though the COF is low. C. She should recommend replacing the reactor immediately to eliminate any risk regardless of operational cost. D. She should reduce the frequency of inspections because the COF is low and there is no immediate threat to personnel or operations. Answer: B. She should implement additional monitoring techniques to detect cracks early and adjust the inspection schedule based on the POF, even though the COF is low. Explanation: in this scenario, Ms. Johnson should prioritize monitoring the reactor for cracks due to the high probability of failure, POF, even though the consequence of failure, COF, is low. The high POF suggests that cracks are likely to progress, and early detection through monitoring can prevent potential failure before it escalates. By adjusting the inspection schedule to focus on this higher risk, she is managing the asset proactively. This aligns with RBI principles, where both POF and COF are considered in risk management decisions, ensuring that resources are allocated effectively to prevent failures and ensure plant safety. Option is incorrect because it disregards the high POF, which is a crucial factor in managing risks, regardless of the low COF. Option C is incorrect as replacing the reactor is likely unnecessary and not cost-effective given that the COF is low. Option D is incorrect because reducing inspection frequency for high-risk assets with high POF could lead to undetected failures. Question 19. Asset integrity and fitness for service evaluation. Which of the following best describes the role of fitness for service, FFS, evaluation in a risk-based inspection, RBI, program? A. FFS evaluation is used exclusively to determine if an asset can be safely operated after an incident of failure. B. FFS evaluation is used to assess an asset's current condition and whether it can continue to be safely operated, even in the presence of defects based on remaining strength and degradation mechanisms. C. FFS evaluation is focused on predicting when the asset will fail, but does not involve any operational assessment. D. FFS evaluation only applies to high-risk assets and is not necessary for low-risk components. Answer: B. FFS evaluation is used to assess an asset's current condition and whether it can continue to be safely operated, even in the presence of defects, based on remaining strength and degradation mechanisms. Explanation: fitness for service, FFS. Evaluation is a critical component in the RBI program that helps determine whether an asset, despite defects, e.g., corrosion, cracks, etc., can continue to operate safely. It involves a detailed assessment of the asset's current condition based on its remaining strength, operational limits, and potential degradation mechanisms. This approach ensures that assets can be safely operated until they are either repaired or replaced, which reduces the risk of catastrophic failures. API 580 and API 579 are guidelines for conducting FFS evaluations and considering defects while ensuring asset integrity. Option is incorrect because FFS is used proactively, not just after failure, to assess whether assets can continue service. Option C is incorrect because FFS is concerned with assessing safe operation, not just predicting failure. Option D is incorrect because FFS is applied to all assets as part of an RBI program, not just high-risk ones. Question 20. Risk ranking and prioritization. Which of the following best explains the purpose of risk ranking in a risk-based inspection RBI program? A. To rank assets based on their market value to determine the frequency of inspections. B. To prioritize inspection resources by identifying which assets, based on their risk, require the most attention to prevent failure. C. To rank assets based on their operational schedule to ensure that inspections align with plant shutdowns. D. To determine the repair schedule for assets, regardless of the associated risk of failure. Answer: B. To prioritize inspection resources by identifying which assets, based on their risk, require the most attention to prevent failure. Explanation: in an RBI program, risk ranking is a crucial step that helps prioritize inspection efforts. It involves evaluating both the probability of failure, POF, and the consequence of failure, COF, for each asset. The goal is to identify which assets pose the highest risk to the plant's safety, operations, and profitability. By focusing inspection resources on these high-risk assets, companies can prevent costly and potentially catastrophic failures. This risk-based approach ensures that the most critical assets are inspected with the appropriate frequency and aligns with API 580 principles. Option is incorrect because risk ranking focuses on risk, not market value, to determine inspection priorities. Option C is incorrect because operational schedules are not the primary focus of risk ranking. This is about risk, not operational timing. Option D is incorrect because the repair schedule should be based on risk assessment, not just arbitrary decisions. Question 21. Scenario question. RBI program documentation. Scenario: Mr. Davis, an RBI coordinator, is tasked with documenting the inspection findings for a critical asset in a chemical plant. The findings indicate minor corrosion, but there are no immediate safety concerns. What should Mr. Davis include in the documentation to ensure it meets API 580 standards for proper risk assessment and communication? A. Only record the corrosion findings and specify that the asset is safe to operate without further actions. B. Document the corrosion findings, the current condition, the potential risks, and recommend a follow-up inspection with a specific time frame for reassessment. C. Record the corrosion findings and recommend the asset be replaced regardless of its current condition. D. Include only a brief statement confirming that the asset is operating normally, as the corrosion is not a significant issue. Answer: B. Document the corrosion findings, the current condition, the potential risks, and recommend a follow-up inspection with a specific time frame for reassessment. Explanation: API 580 emphasizes thorough and transparent documentation of all inspections, findings, and assessments. Mr. Davis should document the corrosion findings, provide a clear assessment of the current condition of the asset, and analyze the potential risks associated with continuing operation. This documentation should also include recommendations for follow-up inspections, based on the risk level identified in the assessment. A proactive approach ensures the integrity of the RBI program and communicates the necessary actions to stakeholders to prevent future failures. Option A is incorrect because it lacks sufficient detail on the risks and follow-up actions. Option C is incorrect because replacement is not justified without further risk assessment or indication of failure. Option D is incorrect because it fails to document potential risks and does not provide an action plan for future monitoring. Question 22. Degradation mechanisms and monitoring techniques. Which of the following is the most effective way to detect corrosion under insulation, QE, in a piping system during an RBI inspection? A. Conducting only visual inspections on external surfaces of the insulation without any additional testing. B. Performing ultrasonic testing and infrared thermography to detect changes in material thickness and temperature differentials. C. Relying solely on historical maintenance records to determine the likelihood of CUI and adjust inspection intervals. D. Using only radiographic testing, RT, for internal corrosion detection, without considering external inspections or other techniques. Answer: B. Performing ultrasonic testing and infrared thermography to detect changes in material thickness and temperature differentials. Explanation: corrosion under insulation, QE, is a major concern in asset integrity management. especially for piping systems where corrosion can occur unnoticed under insulation layers. API 580 suggests employing a combination of ultrasonic testing and infrared thermography as effective methods for detecting CUI. UT measures the material thickness, while infrared thermography identifies temperature differences caused by corrosion or moisture accumulation beneath the insulation, making it possible to identify areas where the insulation may be masking corrosion. Relying solely on visual inspections, option A, or historical records, option C, may overlook hidden damage, while using only radiographic testing, RT, option D, does not address the external corrosion mechanisms adequately. Option is incorrect because CUI is hidden under insulation and cannot be detected by visual inspections alone. Option C is incorrect because historical records cannot replace direct testing of the asset's current condition. Option D is incorrect because radiographic testing is not the most effective method for external corrosion detection, particularly under insulation. Question 23. Role of risk mitigation in RBI. Which of the following risk mitigation strategies is most aligned with the principles of risk-based inspection, RBI, when managing assets prone to fatigue failures? A. Scheduling frequent shutdowns to completely replace assets at regular intervals. B. Applying a prescriptive maintenance schedule based solely on asset age, without assessing actual damage or fatigue. C. Implementing a targeted monitoring program that tracks asset fatigue accumulation and adjusts inspection intervals based on real-time data. D. Ignoring the fatigue risks as long as the asset is still operational, since the failure risk is relatively low. Answer. C. Implementing a targeted monitoring program that tracks asset fatigue accumulation and adjusts inspection intervals based on real-time data. Explanation. In RBI, fatigue failures are typically associated with mechanical stresses that accumulate over time. Instead of following a rigid, prescriptive schedule, option B, or replacing assets too frequently, option A, the most effective mitigation strategy is to implement a targeted monitoring program. This program tracks real-time fatigue accumulation and adjusts inspection schedules accordingly to identify signs of failure before they occur. This approach allows resources to be focused on high-risk assets, ensuring safety and reliability. API 580 recommends dynamic, data-driven decision-making, which allows for more precise risk management rather than relying on arbitrary schedules or ignoring the risks altogether. Option is incorrect because frequent shutdowns and complete asset replacement are typically unnecessary and costly if the fatigue can be managed through monitoring. Option B is incorrect because prescriptive maintenance schedules do not account for the specific operational conditions or real-time asset performance. Option D is incorrect because ignoring fatigue risks can lead to catastrophic failures, which defeats the purpose of implementing an RBI program. Question 24. Scenario question. Implementing RBI program. Scenario. Mr. Harris, a plant manager, is evaluating the implementation of a risk-based inspection, RBI, program for a chemical plant that has been experiencing increasing incidents of minor leaks in several of its pressure vessels. Based on the initial assessment, there is a low probability of catastrophic failure, but the leaks are increasing. How should Mr. Harris proceed with the RBI program to mitigate future risks effectively? A. Focus on inspecting only the high-risk vessels identified by the initial risk assessment and ignore minor leaks in the lower-risk vessels. B. Implement a comprehensive RBI program that includes both high-risk and low-risk vessels, ensuring that leaks are systematically identified and repaired before they escalate into larger issues. C. Ignore the minor leaks for now, as the risk of catastrophic failure is low, and continue with routine maintenance without modifying the inspection approach. D. Prioritize asset replacement for all vessels with leaks, even if the risk of failure remains low. Answer. B. Implement a comprehensive RBI program that includes both high-risk and low-risk vessels, ensuring that leaks are systematically identified and repaired before they escalate into larger issues. Explanation. The key to an effective RBI program is not only addressing high-risk assets but also proactively managing low-risk assets that may present growing issues over time. In this scenario, although the probability of catastrophic failure is low, the increasing incidence of leaks suggests that minor issues could develop into more significant failures if left unchecked. API 580 stresses the importance of addressing both high-risk and low-risk assets to ensure that all potential threats are managed. This comprehensive approach helps identify and resolve small issues before they escalate, thereby improving the overall integrity of the plant. This approach ensures a safer and more reliable operation by addressing all potential risks, Option A is incorrect because ignoring minor leaks may allow small issues to grow into larger, more serious problems. Option C is incorrect because minor leaks, though seemingly low risk, can lead to more significant problems if not addressed. Option D is incorrect because replacing assets unnecessarily can be a costly solution when a more effective monitoring and repair approach is available. Question 25. Risk assessment methodologies. Which of the following risk assessment methodologies best aligns with risk-based inspection, RBI, for evaluating the potential failure of pressure vessels in a refinery? A prescriptive approach that dictates mandatory inspection intervals regardless of the condition of the equipment. B. A qualitative risk assessment method that solely focuses on identifying potential failure modes without evaluating the probability or consequences of those failures. C. A quantitative risk assessment that combines the probability of failure, POF, and consequence of failure, COF, to determine the overall risk and prioritize inspections based on asset conditions. D. An approach that focuses solely on historical failure data to guide inspection frequency without considering the current operational state of the equipment. Answer: C. A quantitative risk assessment that combines the probability of failure, POF, and consequence of failure, COF, to determine the overall risk and prioritize inspections based on asset conditions. Explanation: in risk-based inspection, RBI, the most effective methodology for assessing the risk of failure is a quantitative risk assessment that evaluates both the probability of failure, POF, and the consequence of failure, COF. This combined approach provides a clear, data-driven understanding of both the likelihood and impact of failure, allowing for targeted and prioritized inspection schedules based on actual asset conditions rather than arbitrary intervals or past performance. By factoring in both the risk of failure and its potential consequences, this method aligns with API 580 standards, ensuring that inspection resources are focused where they are most needed. Option A is incorrect because prescriptive approaches are less effective in RBI, as they do not account for actual risk and asset conditions. Option B is incorrect because qualitative risk assessments fail to quantify both the probability and consequences, which limits their ability to prioritize inspections effectively. Option D is incorrect because using only historical data neglects real-time operational conditions, which may have changed since the last failure. Question 26. Damage mechanisms. Which of the following damage mechanisms is most likely to cause failure due to brittle fracture in a low-temperature vessel within a chemical plant? A. Corrosion fatigue due to repeated mechanical stresses combined with corrosive environments. B. Stress corrosion cracking, SCC, that occurs under tensile stress and the presence of specific corrosive agents like chlorine. C. Low-temperature brittle fracture caused by the loss of ductility in materials at reduced temperatures. D. Pitting corrosion, which creates localized holes in the metal surface but does not typically result in catastrophic failure. Answer: C. Low-temperature brittle fracture caused by the loss of ductility in materials at reduced temperatures. Explanation: low-temperature brittle fracture occurs when materials become brittle and lose their ability to absorb energy at reduced temperatures. This is a particular concern in low-temperature vessels where the steel or other materials may experience a loss of ductility, making them prone to sudden and catastrophic failure under stress. API 580 identifies low-temperature brittle fracture as a significant concern for vessels operating in sub-zero temperatures or when exposed to rapid temperature changes, which can lead to instantaneous failure without significant warning signs. Option A is incorrect because corrosion fatigue is a failure mechanism caused by cyclic loading and corrosive environments but not directly related to low temperatures. Option B is incorrect because stress corrosion cracking, SCC, is caused by a combination of stress and specific corrosive agents, not necessarily related to low temperatures. Option D is incorrect because while pitting corrosion can create localized damage, it generally does not lead to sudden catastrophic failure as seen in brittle fracture. Question 27. Scenario question. Implementing an RBI program. Scenario: Ms. Patel, an asset integrity manager, is tasked with implementing a risk-based inspection RBI program for a new pipeline system that will be used to transport hazardous chemicals. The pipeline will operate under varying environmental conditions and will undergo frequent operational changes. How should Ms. Patel approach the development of the RBI program to ensure it addresses potential risks effectively and maintains operational safety? A. Prioritize inspections based solely on the pipeline's age and operational schedule, without considering environmental factors. B. Develop A dynamic, flexible RBI program that evaluates risk based on environmental conditions, operational changes, and historical data to prioritize inspections and asset maintenance. C. Focus primarily on visual inspections during regular operational shutdowns, assuming that operational changes will not significantly impact the asset's integrity. D. Implement a fixed inspection schedule based on industry standards, regardless of the specific risks posed by the pipeline's operating conditions. Answer. B. Develop a dynamic, flexible RBI program that evaluates risk based on environmental conditions, operational changes, and historical data to prioritize inspections and asset maintenance. Explanation. A dynamic, flexible RBI program is essential for a pipeline system that operates under variable environmental conditions and frequent operational changes. API 580 emphasizes the importance of creating an RBI program that can adapt to these changing conditions by considering both environmental factors, e.g., temperature, corrosion potential, and the pipeline's operating history. By assessing risk through a combination of real-time data, operational changes, and environmental factors, TEL can ensure that inspections are targeted where the highest risks exist. This approach minimizes the chance of failures and maximizes asset integrity. Option A is incorrect because it neglects the importance of environmental conditions and operational variability, which are critical in assessing risk. Option C is incorrect because relying solely on visual inspections during shutdowns ignores the need for continuous monitoring and detailed risk assessment. Option D is incorrect because fixed schedules are less effective in addressing variable risks associated with changing operational conditions and environmental factors. Question 28. RBI program documentation and communication. Which of the following best practices is critical for ensuring effective communication and documentation within an RBI program? A. Focusing primarily on detailed inspection reports and neglecting high-level risk assessment summaries for decision makers. B. Creating comprehensive documentation that includes both technical inspection details and executive summaries to communicate risks mitigation strategies and recommended actions clearly to stakeholders. C. Limiting the documentation to a simple record of inspections and repairs to comply with regulatory requirements without including the rationale for decisions made during risk assessments. D. Using only verbal communication to convey findings from the inspections, as documentation is often unnecessary for high-risk components. Answer. B. Creating comprehensive documentation that includes both technical inspection details and executive summaries to communicate risks mitigation strategies and recommended actions clearly to stakeholders. Explanation. API 580 emphasizes the importance of clear, thorough documentation and communication in an RBI program. It is essential to provide both detailed technical information and high-level executive summaries. The detailed records help track inspections, evaluations, and repairs, while the executive summaries allow decision-makers to quickly understand the risk landscape, proposed mitigation strategies, and critical findings. Proper documentation ensures that both technical teams and stakeholders are aligned in their understanding of asset integrity and the need for corrective actions. Option is incorrect because focusing only on technical details without high-level summaries can leave decision-makers without the necessary context to act. Option C is incorrect because simply complying with regulatory requirements without explaining the rationale behind decisions could lead to gaps in understanding and missed opportunities for proactive risk management. Option D is incorrect because verbal communication alone is not sufficient to ensure clear, traceable records that are essential for compliance and decision-making. Question 29. Consequence of failure, COF calculation. When calculating the consequence of failure, COF, for a critical pipeline transporting flammable liquids, which of the following factors should be given the highest priority in the assessment? A. The cost of replacing the pipeline, including materials and labor, in the event of failure. B. The potential environmental impact, such as contamination of nearby water sources and wildlife. C. The historical maintenance records of the pipeline, including past leaks and repairs. D. The operational downtime cost, including production delays and revenue loss during repairs. Answer. B. The potential environmental impact, such as contamination of nearby water sources and wildlife. Explanation. The consequence of failure, COF, refers to the impact that a failure would have on safety, the environment, and operations. In the case of a pipeline transporting flammable liquids, the environmental impact should be given the highest priority in the COF calculation. A failure could lead to significant environmental damage, such as the contamination of water sources and harm to wildlife, which could result in severe regulatory and legal consequences. API 580 emphasizes evaluating the severity of environmental consequences when assessing the risks of failure, particularly in systems carrying hazardous materials. Option A is incorrect because while the cost of replacing the pipeline is important for assessing financial risk, environmental impact generally carries more weight in assessing the severity of failure consequences in systems transporting hazardous materials. Option C is incorrect because maintenance records are important for assessing likelihood but are less relevant to the consequence of failure. Option D is incorrect because operational downtime costs are significant but do not typically outweigh environmental consequences when evaluating COF in hazardous material transport systems. Question 30. Scenario question. Asset integrity in RBI. Scenario: Mr. Johnson, an inspection engineer, is tasked with developing an RBI program for a refinery's high-temperature piping system. The piping is made of carbon steel and operates at temperatures above 500 degf, which increases the likelihood of creep damage. In the last inspection cycle, no significant degradation was noted. How should Mr. Johnson adjust the RBI program to address the potential risks associated with high-temperature operation? A. Maintain the current inspection schedule since no significant degradation was found, as high-temperature operation may not cause immediate failures. B. Adjust the inspection frequency to account for the potential creep damage caused by sustained high temperatures and stress, even if no visible degradation has occurred yet. C. Increase the inspection intervals to reduce costs, as the system has operated without visible degradation for an extended period. D. Recommend replacing all affected piping sections with higher-grade materials to completely eliminate the risk of creep damage. Answer: B. Adjust the inspection frequency to account for the potential creep damage caused by sustained high temperatures and stress, even if no visible degradation has occurred yet. Explanation: Creep damage is a progressive failure mechanism that occurs in materials subjected to high temperatures and sustained stresses, even if no visible degradation is noted during inspections. API 580 advises adjusting the inspection frequency to account for the long-term effects of high-temperature operation. This ensures that any subtle damage due to creep is detected before it leads to more significant failures. The system may still be in the early stages of creep damage, and increasing inspection intervals allows for proactive monitoring to prevent failure before it occurs. Option is incorrect because failing to adjust for the potential of creep damage may lead to unanticipated failures. Option C is incorrect because extending inspection intervals without accounting for the potential for creep damage could result in missed opportunities to address the issue early. Option D is incorrect because replacing the piping entirely is unnecessary and costly if the issue can be managed with more frequent inspections and targeted monitoring.